Okay, let's just get right to it. What if I told you there's a way to study less, but actually remember more? Sounds wild, right? Well, today we're going to break down the science behind a method that does exactly that. It's a total game changer for how you learn.
I know, it sounds a little too good to be true. Cut my study time in half and remember more? But seriously, this is exactly what happens when you combine two incredibly powerful learning techniques. And in this explainer, we're not just going to look at the why, the science, we're also going to dive into the how, the actual engineering that makes this whole thing tick. All right, so first things first, we have to understand our main opponent here, the act of forgetting. And look, this isn't some personal failure on your part. It's just how our brains are wired. It's a feature, not a bug. In fact, way back in the 1880s, a psychologist named Hermann Ebbinghaus became obsessed with this and was the first to really study it systematically. And guess what? What he discovered back then is still totally on the money today. Our memory just naturally fades.
And this curve? It shows the problem perfectly. You learn something new, you're at 100%. But then, whoosh, within just a few days, that memory takes a nosedive. The real secret, the key to all of this, is to catch it at just the right moment. You want to review that info right before it falls off the cliff. When you do that, you're not just remembering it, you're reinforcing it. And as you can see, the next time it starts to fade, the slope is way, way less steep.
So the big question is, how do we fight this forgetting curve? The answer isn't about cramming or brute force. No, it's about being smarter. It's a two-part strategy. We're talking about active recall and spaced repetition. Think of them as the perfect 1-2 punch for making memories that actually stick around for the long haul.
Okay, let's break down active recall first, because this one idea basically flips everything you were probably taught about studying on its head. You know, endlessly rereading your notes, highlighting entire textbooks until they're neon yellow? That's all passive stuff, and honestly, it barely works. Active recall is the complete opposite. It's about closing the book and forcing your brain to pull that information out of thin air. It's like giving yourself a tiny quiz. Yeah, it feels harder, but that's the point. The science is super clear on this. That little bit of struggle is precisely what forges strong, durable memories.
All right, on to part 2 of our power duo, spaced repetition. If active recall is the what, the action of pulling info from your brain, then spaced repetition is the when. It's all about timing. You can think of it like a super smart personal assistant for your brain. It's not just randomly reminding you to study something. It's an algorithm that figures out the absolute perfect moment to show you that information again right before you forget it, for maximum effect.
So let me show you how this actually plays out. You learn something and recall it correctly for the first time. Great. The system says, okay, see you in 1 day. You get it right again. Now it's not going to bother you for maybe 6 days. Nail it again? Boom, 15 days. See the pattern? The gaps between reviews get bigger and bigger, exponentially. This is so efficient because it focuses your valuable time only on the stuff that's on the verge of slipping away. And this isn't just guesswork, right? It's not random. There's a real engine running under the hood here, an algorithm that's crunching the numbers and fine-tuning these schedules for every single fact you're learning. So let's pop the hood and see how this thing actually works. So one of the original and still one of the most popular algorithms for this is called SM2. It actually came out of a project called SuperMemo way back in the 80s. And what's amazing is that it's just this set of simple, really elegant rules. But those rules are so powerful, they form the backbone of countless flashcard and learning apps that millions of people use every single day. Now, here's where the real magic comes in. The algorithm learns from you. It's a feedback loop. Every time you review something, you tell it how you did. Did I get it instantly? Was it a struggle? Did I completely blank? If you say you forgot it, boom, the algorithm resets the clock and shows it to you again very soon, like tomorrow. But if you say, yep, got it, no problem, the algorithm goes, great, I won't bother you with this for a long time. And at the core of this SM2 algorithm, there's this key little number called the easiness factor, or EF. Every single flashcard or fact you're learning has its own EF, which starts at a default value of 2.5. Think of it as a difficulty rating. If you nail a card, its EF might go up, which means the next review gets pushed even further away. If you struggle, the EF goes down. This is how the system tailors the entire learning schedule just for you, and just for that specific piece of information. Okay, this all sounds great when you're talking about, I don't know, 20 or 30 flashcards, but what happens when you scale up? What if you're a developer trying to build an app that has to manage thousands of cards for thousands of users? How do you keep it fast and efficient? This is where we shift gears from learning science to some really cool and elegant computer science. Just picture the challenge for a second. You've got, say, 10,000 flashcards in your system. Each one has a different due date stamped on it. Now, every single time a user opens the app, you have to find the one card that's most overdue. The brute force way, you'd have to scan all 10,000 cards every single time. That's insanely slow. It would never work in the real world. And the solution to this problem is, well, it's just beautiful. It's a data structure called a min heap. The easiest way to think about it is like a self-organizing priority queue. For us, the priority is just the earliest due date. And here's its superpower. No matter if you have 10 items or 10 million items in this thing, it always keeps the one with the highest priority, the earliest due date, right at the very top. It's just sitting there, waiting for you. It's practically instantaneous. So this lets you create this perfect, super efficient loop. Here's how it goes. Step 1, the system just grabs or pops the card from the top of the min heap. That's your next review. Step 2, you look at it and rate how well you remembered it. Step 3, the SM2 algorithm takes your rating and calculates a new due date way off in the future. And finally, step 4, the system just pushes that card right back into the heap, and it automatically finds its new correct spot in the priority list. That's it. It's a simple, elegant cycle that just keeps on turning. And here is the beautiful payoff for all that clever engineering. You see this notation OR log n? That's big O notation, and it's how computer scientists talk about efficiency. All you need to know is that it means this system is ridiculously scalable. The N there stands for the number of items. This means you can go from having 100 flashcards to having 1,000,000 flashcards, and the time it takes to find the next one barely even budges. It stays lightning fast. This is the kind of efficiency that literally makes all of our modern learning apps possible. Okay, wow, so we've taken a pretty wild ride, right? We started with the psychology of how our brains forget things and went all the way down into the nitty-gritty of data structures. So let's zoom back out and tie this all together. What are the big takeaways here, whether you're trying to learn something or maybe even build something?
So here's your playbook, nice and simple. If you're a learner, stop rereading. Seriously. Start testing yourself. That's active recall. And then trust the system. Let a spaced repetition algorithm handle the when for you. And if you're a builder or an engineer, the lesson is just as powerful. Anytime you need to manage a list by priority, finding the next due thing, for example, a min heap should be your go-to tool. It is the key to performance and scalability.
And that leaves us with one last, much bigger question to chew on. What we've just laid out is the blueprint for a single user. But what if you wanted to build this for millions of users? How would you manage millions of different people, each with their own personal min heap of thousands of items? Now that is the next level of the engineering challenge. But hopefully, you now have the building blocks to start thinking about how you'd solve it.